do some review here. He's got it. Eli?
It's on the very front page on the quick review number 2.
I already did all those.
Yeah, I know you already went over it.
Yeah, so find another one similar to it, and I'll be happy to do it, but I'm not gonna do the same problems over again. All right, who found one we haven't done yet? We've done all the quick reviews, so don't look there, unless you wanna find one similar to it. Meg?
Number 8 on the Christmas gift.
Christmas thing, number 8. So we have a squirrel on top of a tree, looking at an acorn on the ground. The tree is 15 meters tall. The angle of depression is 19, and remember, this is where we're putting our angles of depression and elevation. How far is the acorn from the base of the tree? So what do we do with a problem like this? We need an equation, and the equation's gonna come from SOHCAHTOA. So you just have to figure out, am I gonna do a sine, cosine, or a tangent equation? Well, what do we have here? What do we have? That's gonna be a tangent, right? So tangent 19, the angle always goes with the tangent or the sine or whatever. So tangent 19 equals opposite over adjacent. So then we clear fraction, multiply by x, and then divide to get x by itself. So x tan 19 equals 15, so x equals 15 divided by tan 19. Type it in on the calculator, that's an easy one, 15 divided by tan 19. Make sure you're in degrees, and I got 43.56 meters. Okay, and we'll raise our hand next time because there were others that want to too. But all right, so we'll do number 4. Find the value. Who asked for this? Are we good here? We good?
Yeah.
Okay. Find the value at number 4 on the same sheet. Find the value of the other functions if the tangent of Q is 3/5 and Q is in quadrant 3. So I'm going to draw my triangle in quadrant 3. Here's Q, and its tangent is 3/5. What does that mean? If the tangent's 3/5, opposite is -3 and adjacent is -5. Where'd those negatives come from? In the third quadrant, right? So they didn't show up in the tangent because they canceled when I did 3/5. But they both are negative in that quadrant. What's my third side of my triangle then, my hypotenuse? Don't wait on me to do it, you do it. Make sure you can do the Pythagorean theorem correctly and come up with the right hypotenuse. What is it?
34.
Square root of 34, 25 plus 9. So now it's just, we did one before lunch where we just have to find everything. So sine, I guess it's Q. Sine, cosine, tangent. Well, that one I knew already. So cotangent is 5/3. I need secant and cosecant. So looking at the picture, it looks like the sine is opposite over hypotenuse, -3 over root 34, or -3 root 34 over 34. Cosine is -5 over root 34, adjacent over hypotenuse. And then these guys are the reciprocals. So secant is reciprocal of cosine. Yes, you have to know that. Secant is reciprocal of cosine. And cosecant is reciprocal of sine. Okay? All right, who else? Eli? So one of the sheets is just called review sheet 4, and it's problem number 10. You're not gonna believe this, like, we already did that one too, and it was the exact same numbers. It was on a different sheet, but we did it before lunch. With those exact same numbers. I promise. Didn't we?
Yeah.
That's what I thought. All right, let's have a new one here. In
On the pretest, chapter 4, number 12.
pretest, so now the pretest sheet number, which one?
12.
12. This was on the quiz you just took. We have some kind of wild combination of periodic functions. And we want to know what the period of it is. What is the period of this thing? Well, the answer to that question is going to be determined by looking at the periods of each piece, right? So, what is the period of this first piece?
2 pi over 1
2 pi over 1/2. 2 pi divided by this coefficient gives you your period. Abe, you awake back there?
Yeah.
Okay, try to stay focused, man. We have to know how to find the period in lots of different kinds of problems. Graphing, writing equations. Period is 2 pi divided by the coefficient on x if it's a sine or a cosine, which this is. So what's 2 pi divided by 1/2?
4 pi.
4 pi. So the period of this is 4 pi, which means that every 4 pi, this curve starts over. Every 4 pi. So it starts over at 4 pi, 8 pi, 12 pi, and so on. Now, what about this one? What's the period of this one? 2 pi divided by 2/3?
Yeah.
Which is 2 pi times 3/2, which is 3 pi. So that one starts over again every 3 pi. So 3 pi, 6 pi, 9 pi, there it is. The first time they match is the period. So the period is 12 pi. Okay? All right, what else? These are good questions, so let's have some more.
On the review sheet 4, not number 3 on that part, but on the other side, like the printed words that are like handwritten, number 3.
So 26, number 3?
Yeah.
Okay, so we're on review sheet 4, and then problem 26, part 3 of it. So we got a ship sailing from port on a course due north. Okay, so we remember due north is straight up. So here's my ship sailing on a course due north at a speed of 12 knots for 2 hours. So speed of 12 miles an hour for 2 hours. So how long is that black line right there? 12 miles an hour for 2 hours. 24 miles. And they're nautical miles, but it's like 24 miles. It's 24. Then it turns on a course of due west at a speed of 13 miles an hour for 1 hour. So how long is that one? I'm gonna make that one a little bit longer. So here's my due north, and he's 24. Due west, how long is that one? 13. At this point, which is right here, what is its distance and direction from port? So here's port. Here's where he is. There's his distance right there. Can we find the distance? That's due north, that's due west. Isn't that a right angle? we find that distance right there? How? Pythagorean theorem, all right. So 24 squared plus 13 squared, square rooted. What'd you come up with? 27.29 nautical miles. All right, that was easy. Now we need its course. Now, its course will be this right here. Well, can we find this angle right here? Let me call it X. Can we find angle X? Yeah, it's just like the squirrel problem. Trying it sideways, but it's just like the squirrel problem. What have I got here? This side is opposite, this side is adjacent. So tan X equals 13/24. How do I type that into my calculator? Second tangent. So X is second tangent, 13/24. What'd you get for that angle? This angle right here. This is not the answer. What did you get for that? 28.44 degrees. So what course is that? What's the big orange angle then? 360 minus that, so it's 331.56 degrees. Remember, navigationally, you're measured from due north clockwise. So all the way around to where he is. Amanda?
Can we do on that same page, number 12, B?
Same page, number 12B, did it yesterday. I didn't refer to this page, but I took it off to do it, so look at your notes yesterday, did it?
I
Yeah, but I get page and I'll be back to you.
number 3 on the Christmas gift.
Christmas, number 3. A bicycle with a 24-inch diameter tires, traveling at 8 miles an hour. How many revolutions does each tire make per minute? So this is a big factor label problem. So we're starting with 8 miles per 1 hour. That's what we're given. And we want to end up in revolutions per minute. I don't know how long it's going to take. I'll put it over here. We want to end up with revolutions per minute. So I have miles per hour. I want to end up with revolutions per minute. And always the key to these problems is remembering that a revolution is a circumference. A revolution is once around, right? And that's a circumference. So if the diameter of the wheel is 24 inches, I'm just gonna make that feet right now. So the diameter is 2 feet. What's the radius? 1 foot. How do we find circumference? Well, pi d or 2 pi r. I actually always think of it as 2 pi r, but that's the same as pi d. So since the radius is 1, a circumference is 2 pi feet. So I'm gonna come over here and I'm gonna say a revolution, 1 revolution is 2 pi feet. Now I put revolutions on top because that's where I want them in the end. So I said 1 revolution is 2 pi feet. All right, how am I gonna get minutes? I need minutes. How am I gonna get it? 1 hour is 60 minutes. So I've got my minutes now where I want it, and I got my revolutions where I want it, that's good. But I gotta get rid of miles and feet, I gotta get rid of those gotta cancel. So what do I know about miles and feet? There are 5,280 feet in 1 mile. So now the miles will cancel, the feet will cancel, and the only units I have left are revolutions per minute. So then I type all that in on my calculator and type all that in on my calculator, being very careful about the division part. So let's practice this. So I'm gonna take 8, I guess all I have on top is 8 times 5,280. Okay, then I gotta divide by 2 pi. So divided by parentheses 2 pi. And I hit equals, and then divided by 60. So make sure you got your answer was 112.05 revolutions per minute. Make sure that's what you ended up with. Okay, all right. Yes, Amanda, back to you now.
I just had a question about if it says like evaluate on a calculator and it's like cotangent.
Is that what?
If it's like cotangent of like 10, to put on the calculator, would you do 1 divided by that?
One kind of a tangent.
Yeah.
Yeah, okay. Now you gotta be careful about, when you said 10, if that's degrees,
Yeah.
make sure your calculator's in degrees. If it's radians, make sure you're in radians. But yes, it's 1 divided by tangent. To type a cotangent in on your calculator, it's 1 divided by tangent. Yeah. All right, who else? Who else? Yeah, Kara?
Review sheet 4, number 25.
Review sheet 4, number 25. How large is an angle determined by a 2/3 clockwise rotation? Now, first of all, clockwise means this way, right, people? And when angles go this way, they're negative. So whatever it is, it's going to be negative because it's going clockwise. Now, what's a full rotation? 360. If I'm going 2/3 of 360, what is that? 2/3 times 360. 240? It's 2/3. 2/3. So your answer would be negative 240 degrees. A revolution, a rotation, it's all 1 time around 360. Okay? Now, again, don't get confused. The only time we start angles here is if it's a course, a direction, a compass. Otherwise, we're gonna start here, and this is negative. All right, what else? Yeah,
Maybe number 20 on the same sheet.
same sheet, number 20. What is the period of the absolute value of the sine plus 1? This is a great review question and current material question. Absolute value of sine plus 1. All right, so let's stop for a second and think about, what does a sine curve look like? Just a straight, regular sine curve. Starts here. That's it, right? And that's 2 pi. Now, what if I take the absolute value of that? Who remembers from way back in chapter 1? When you take an absolute value of a function, what does it do? Okay?
Oh,
It takes the bottom and flips it up. Okay? So anything that's positive stays positive, but anything that's negative becomes positive. So this is a picture of the absolute value. All right? Now want you to look at that for a second. What's the period of that? Just pi. Doesn't this repeat every pi? So the period of that picture is pi. Is that gonna change if I lift it up one? No. So what's the answer to the question? Because when you take the absolute value, you no longer have valleys, you have just hills. Man, whoever wrote this review sheet did a great job. All right? Yep. Same sheet. Name two angles coterminal with pi over 7.
Yeah, I was doing like that part, like, is that?
That just means ditto. That means redo what it said above. I just didn't recopy it all.
That's wrong.
That's all. So you know how to find coterminal angles, add or subtract 2 pi. All right, what else? Van, was your hand going up? Should it go up?
I'm alright.
All right. We're going to find out next Tuesday how right you are. All right, who else? Come on. Listen, if we're gonna review again tomorrow, we gotta come up with some questions, kids.
Same sheet 23.
Same sheet 23. With a calculator, just type the buttons through. Just type it exactly as it is. So with a calculator, tangent, second sine, 7 divided by 8, 1.807.
Anybody doing that calculator?
Yep, there sure is. That would be exactly, without a calculator, means exactly. So that would be, we draw a picture of this angle. This is an angle. The angle whose sine is 7/8. So there's a picture of the angle whose sine is 7/8. What is the missing side of this triangle then? It is not 6. I don't know who said 6. It's not 6. Square root of 15. Because it's 64 minus 49. So it's the square root of 15. Now, Drew, what do I want to know? I want to know the tangent. Tangent would be 7 over square root of 15. Right? That's the exact. Why are we packing up? It's 13. We got 2 minutes to go.
It's at least a lot of questions.
Oh, okay, so number 21. This will not be on the test. It's just information for you to know. That another notation for that is arc sign. These mean the same exact thing, just FYI. Depending on the book you're reading, or the math book you read, you know, it could use that notation, and that means the same thing as this. Okay?
For the ones where it's like you have to find the other sides here, you just whatever both sides you have, you add them together and then square root it, or does it have to be on the spot?
Pythagorean theorem?
Yeah.
A squared plus b squared equals c
Okay.
squared. Every time. All right. First time tomorrow, I have to ask for a question. We're pulling out our chapter 5 notes. Section 5.1 and 5.2 are my favorite sections of the whole year. I can't wait to get started.